Welcome back, Algebra 2 students, to another Regents review video. This is the Algebra 2 Common Core Regents exam for August 2017. These are going to be the solutions to parts 2 through 4 of this exam. These are the open-ended response questions. These are going to take a little bit longer than the multiple choice sections because these are definitely more in-depth and they require some writing and explanation. So, before we get into the questions, do not cheat off of this video. It's not worth it. It's also not ethical, and you're really doing you're not doing yourself a favor by cheating off of this video to get some homework done. Do the problems by yourself. Make sure you understand the material. Then if you're having trouble, by all means, come back to me. I'm always here. Make sure to hit the subscribe button down below. Consider becoming a patron on my Patreon page. I would greatly appreciate the financial support to keep this channel going for a very long time. And make sure that you visit my website at www.nysmathregentsprep.com for more math content in Algebra 2 and your future mathematical subjects. And I use the TI Inspire CX calculator heavily for the Algebra 2 course. I use it in all courses, but I use it heavily for the Algebra 2 course, and it is quite a powerful tool. That link could also be found on my website under the section titled as the TI Inspire CX calculator. That links you to Amazon or the Texas Instrument page to download some software for your computer. All right, without further ado, let's take a look at number 25. These are the part 2s. These part 2 questions. Now, remember, part 2s, the part 2 section questions should be rather quick. You know, you should be spending no more than 5 minutes figuring these problems out. It's the part 3s and 4s that require more in-depth understanding and knowledge. So 25 says, explain how -8 raised to the 4/3 power can be evaluated using properties of rational exponents to result in an integer answer. Honestly, I'm not a fan of these questions because I just don't understand how you could explain writing this as a integer answer. I've done it in previous videos. I was just never comfortable with writing it. But basically, this is what you're doing. 4 is your power. 3 is a root. Another way that you could write this is the cube root of -8 to the 4th power. Or basically, you could even do the cube root of -8 and raise this whole answer to the 4th power. Either one is correct. So in order to explain this, you could just say this. The integer -8 can be, and I'll put this in quotation marks, cube rooted to yield a result of -2. Then raise this answer to the 4th power. That's basically it. So it says explain how this could be evaluated using property. Now, just in case, just write down the number 16 because that is what this is actually equal to, because -2 raised to the 4th power is 16. That's how you, I guess, properly explain how you could answer that question, but that's essentially what it's asking you to do. Number 26, a study was designed to test the effectiveness of a new drug. Half of the volunteers received the drug. The other half received a sugar pill. The probability of a volunteer receiving the drug and getting well was 40%. What is the probability of a volunteer getting well given that the volunteer received the drug? So, let's calculate the probability. Let's calculate the probability of the people who got well and received the drug. Well, the probability of getting well and receiving the drug is 40%, which is just the same thing as 0.4, right? Now, the probability of receiving that drug, well, that's just 50% because they split up half of the volunteers. So you have a 50% shot of receiving that drug and not a sugar pill. Now, the probability of getting well, given, this vertical line means given, the probability of getting well given that they receive the drug, well, what is that going to be? Well, that's just the probability of getting well with the drug, so that's just 0.4, dividing it by the probability of getting the drug in the first place, So 0.4 divided by 0.5, that's just going to be 0.8. So that could be your answer. Or you could write this as 80%. All right, so those are the two answers expressed differently. All right, that's your answer, 80% or 0.8. Moving on to 27. Verify the following Pythagorean identity for all values of x and y. So, how do we do this? Well, honestly, it's probably in your best interest to go ahead and basically distribute, everything here. So, write this twice, distribute, write this twice, distribute, and just raise all this to the second power. So, in order to do this, how do we do it? Take x squared plus y squared, x squared plus y squared, and this is equal to x squared minus y squared, x squared minus y squared, plus 2xy squared. Okay, so I just wrote that and expanded everything. So let's go ahead and solve this. Distribute this, first outer inner last, first outer inner last. We get x squared plus x squared y squared plus x squared, plus x squared y squared plus y to the fourth. I'm going to move this over real quick because I definitely need more room. This is equal to x squared. No, sorry. No, why am I saying x squared? It's x to the fourth. It's x to the fourth. X to the fourth minus x squared y squared minus x squared y squared plus y to the fourth plus, now 2 squared is 4, x to the second power is just x squared, and y to the second power is just y squared as well. So now, this is our, okay, we could simplify this a little bit more. We could say this is x to the fourth plus 2x squared y squared plus y to the fourth. This is equal to, let's go and combine like terms over here. This could combine to this, which could also combine to this over here. So this is just x to the fourth. Now, this is really minus, so these two terms over here, this is minus 2 x squared y squared. Well, 4 minus 2 is just positive 2. So this is 2 x squared y squared plus y to the fourth. And ladies and gentlemen, we actually just proved this Pythagorean identity. We worked on both sides of the equal sign, and we are good to go for this question. We just proved that they're equal. That's it. Done. Moving on to number 28. Mrs. Jones had hundreds of jelly beans in a bag that contained equal numbers of 6 different flavors. Her student randomly selected 4 jelly beans, and they were all black licorice. Her student complained that and said, "What are the odds I got all of that kind?" Mrs. Jones replied, "Simulate rolling a die 250 times and tell me if 4 black licorice jelly beans is unusual. Explain how this simulation could be used to solve the problem." Well, okay, hold on one second. Let me read this again because I do know what it's asking, but it just sounds weird. So Miss Jones has hundreds of jelly beans in a bag. The student selected 4 jelly beans out of the bag, and they were all black. Okay, she complained that, why would I get all 4 that are black and not like other colors or whatever it was? And Mrs. Jones replied that, all right, take a die, a dice die, a rolling cube, and roll it 250 times, and tell her if you get 4 black, and tell her that getting whatever number is unusual. So explain how this simulation could be used to solve the problem. Well, here's your answer. It's kind of annoying, but it is true. So the student, right? The student can choose any number that they want. So the student can choose a number to represent black jelly beans. Then they could see how many times that number can be rolled 4 times in a row after 250 simulations. So here's what I'm getting at. If I could write the number 250. So what's really going on here? So they're basically saying, and I don't know why they're saying it, but Mrs. Jones is saying, all right, take a rolling cube, pick any number to represent black licorice, because in the bag there are 6 different color jelly beans. So let's just say red, orange, yellow, green, blue, and black. Okay? The student chose 4 black, and they're complaining like why did I get 4 black? And Miss Jones said, all right, take a rolling cube, roll it 250 times. Let's just say black represents the number 2. Let's see if you get 2 4 times on the first 4 tries, and run a simulation. And how many times do you get the number 2? So basically that's what's going on here. I don't know why they're corresponding to each other, but that is how it works. Okay? So that's how you do that question. Kind of in my opinion, that's a dumb question. All right, moving on to question number 29. While experimenting with her calculator, Candy creates the sequence 4, 9, 19, 39, 79. Right, a recursive formula for Candy's sequence. Honestly, that looks like a geometric sequence. It might be a geometric sequence, might be arithmetic. I'm not so sure yet. So it looks like for the first part, it looks like we're adding by 5. Then all of a sudden we're adding by 10. Then all of a sudden we're adding by, looks like 20. Then all of a sudden it looks like we're adding 40. So, but all of that could be represented as multiplying by 2. Actually, can it? Okay, I'm going to phrase it a little differently. You're not multiplying the numbers themselves by 2. You're multiplying the numbers here. So like so to get from 5 to 10 to 20 to 40, you're multiplying these by the number 2 to get to the next number. So here's the problem though. It can't. Oh, actually, they're not asking for. Okay, so they're asking for a recursive formula. So the recursive formula, you're just saying, all right, a sub 1 is whatever the first term is, and a sub n is equal to a sub n minus 1 plus whatever number is over here. Well, the first term we know for sure is 4. Okay, well, what is the next thing that we're going to write here? Well, what we're doing here is we're taking the previous term and we're multiplying by the number 2 and adding by 1. You're probably thinking, well, I don't know what you just said. So suppose, and let's just verify that this works. Suppose we have a sub 2. We're trying to find the second term. Well, that's just going to be 2 times a sub n minus 1. Well, what's a sub 2 minus 1? That's a sub 1. A sub 1 is 4. And you're adding on the 1. That's just going to be 8 plus 1, which is 9. And that's clearly the second term. And if you don't believe me, let's try a sub 3. A sub 3 is just going to be 2 times a sub 3 minus 1 plus 1. That's just 2 times a sub 2, which is the number 9, plus 1. That's just 18 plus 1, which is 19. You see what they're doing here? They're taking the previous term, multiplying by 2, then adding by 1. And we just confirm that using our knowledge. So we know for sure that this is actually the recursive formula that Candy is looking for. That was a hard recursive formula to do on a part 2. But then there's a follow-up question. All right, this is an easy one. Determine the 8th term of Candy sequence. So we are given 1, 2, 3, 4. We're given 5 terms. We need to find the 6th, 7th, and the 8th. Because for recursion, you need to use the previous term to get the next. So we need to find a sub 6, a sub 7, and a sub 8. So a sub 6 is 2 times the previous term, which is 79 plus 1. That's 159. The 7th term is 2 times the previous term, which is 159 plus 1. That's going to be 319. The 8th term is 2 times the previous term of 319 plus 1. That gives you an answer of 639. So, ladies and gentlemen, a sub 8 is 639. And that's your answer. Perfect. Moving on to number 30. In New York State, the minimum wage has grown exponentially. That's a good thing. In 1966, the minimum wage was $1.25 an hour, and in 2015, it was $8.75 an hour. What is it now? $10? As of 2018? $10, I think. Algebraically determine the rate of growth to the nearest percent. Well, the rate of growth. You need to use some sort of formula. Well, since it's saying that it is growing exponentially, maybe you could use the exponential formula, which is a of t is equal to p times 1 plus or minus r raised to the t power. Yes, It's this formula that you learned back in Algebra 1, right? So it's asking you, find the rate of growth. Well, the rate of growth is you're solving for R. You're solving for R, okay? Well, how do we solve for R? Well, the final amount that we're looking at is 875. So this is A of t, 875, is equal to the principal. Well, the starting amount, the starting wage was $1.25 times 1 plus or minus the rate raised to the t power. Well, how much time went by from 2015 back to 1966, or from 1966 to 2015? That's 49 years. Just take 2015 minus 1966. That's 49 years. Now, we need to solve for R. Divide by $1.25 first. Okay? So we get, when you divide this properly, you get 7. That is equal to 1. Now, I'm going to change this a little bit here. It's plus R because it's an increase. It's exponentially going up. So it's just a positive R raised to the 49th power. Now, to solve for R, and I know it sounds crazy, take the 49th root of this number. I know, right? Never heard of that before. Take the 49th root. It's going to be a very, very small number. But that cancels anyway. So it's the 49th root of 7 is equal to 1 plus R. Well, the rate is the 49th root of 7 minus 1. Well, what is that going to be? Let's type it in. The 49th root of 7 minus 1. 0.04. Okay, 0.04. So the rate is 0.04. And it says algebraically determine the rate of growth to the nearest percent. Well, in percent, that's just 4%. Ladies and gentlemen, that is the answer to that question. 4% is your answer. Moving on to question number 31. Oh, I saw this one. My stomach drops. This is a new question on the Algebra 2 Regents. And I should add this again to my facts you must know cold for the Regents exam. You see, like those study guides that I make, it takes a couple rounds of testing to go through, and I need to know what's on the exam. It says algebraically determine whether this function is odd, even, or neither. Now, I'm sorry, you could look at this and say even function. Even function. It's the fourth power, the second power, and this is actually x to the 0 power, and 0 is an even number. So you know it's even, right? But it specifically says algebraically determine. So, unfortunately, you need to show, in this case, j of x, so you need to show that j of x is equal to j of negative x. Why am I saying that? Because all even functions are reflected over the reflexive over the y-axis. And when you reflect, think back from geometry. When you reflect over the y-axis, given a coordinate xy, in order to reflect this point over the y-axis, you negate the x, keep the y. And that's exactly what we're doing. We're negating the x. Okay? So, how do we do it? We have j of negative x. We need to show that the original equals the negation. Let's go ahead and do that right now. And I'll tell you why it works. If it's an even function, you should have even powers of exponents, right? And if you have even powers, I don't care how negative the answer is. If you have an even exponent, if you have a negative raised to an even exponent, it's going to give you a positive answer, right? So notice how x to the fourth, x squared, those are all positive exponents. So let's go ahead and plug in negative x into these and let's see what we get. So we have j of negative x is equal to negative x to the fourth minus 3 times negative x squared minus 4. So we have j of negative x is equal to, well, negative x to the fourth is just, hey, what do you know? X to the fourth. This is minus 3. What is negative x squared? Oh, it's x squared minus 4. Hey, we just showed that j of x is equal to j of negative x. So therefore, we just proved that this is, in fact, an even function. Your answer is even, and that's how you show your work. Moving on to number 32. On the positive axes below, sketch a possible function P of x is equal to x minus a, x minus b, x plus c, where a, b, and c are positive. A is greater than b, and P of x has a positive y-intercept of d. Label all intercepts. So, please don't overthink this one. First and foremost, it's saying where a, b, and c are positive. That's important information. If a, b, and c were negative, it'll change the whole story of this polynomial. So, notice how we have x minus a and x minus b. These are actually positive x values. So they're somewhere in this vicinity. X minus c is somewhere in this vicinity, because I'll tell you right now and why that's true. Given P of x is equal to x minus a, x minus b, x plus c, we set all of this equal to 0 and solve. We have x equals a, x equals b, x equals negative c. And they just said in the instructions that a, b, and c are all positive answers. So positive, positive, and it's a negative of a positive answer, which is negative. So therefore, we know for a fact that a and b are somewhere over here and c is over here. Now, but a is greater than b. So therefore, b could be over here and a has to be greater than b. So that's important information too. And c is somewhere over here, it's negative. So far, so good. I hope that we're not confused yet. Or so far. Then it says a positive y-intercept of d. Great. Draw yourself a positive y-intercept where it crosses the y-axis and label that as d. Now all you got to do is sketch the function. Well, it's a cubic function. So go ahead. I'm going to do this the very best I can. And sketch. That's pretty good for me. That, ladies and gentlemen, is a possible answer for P of x. It's just a cubic function, and I just satisfied all of those conditions appropriately. Your answer is shown right there. Now, of course, you could do, actually, you could, if you want to, you can make this positive and make this n negative. That's perfectly fine as well. You just can't be making, like, both point in the same directions, okay? The end behavior, that is. Moving on to 33. We're moving on to the part 3s here. These are not necessarily more challenging, but a little bit more in-depth. Show for all values of p that this is equal to this. Show for all values of p that this is equal to this. No, sorry. I'm saying show. Why? What's wrong with me? Okay, you know what? It's late. Solve. I was asking, like, show? What does that mean? Solve for all values of p. God, I need sleep. So, you're solving. That's important. The least common denominator, I'm just looking at this. Your least common denominator looks like it's going to be p plus 3 and p minus 5. So remember what I always say. You multiply by what you need on both the top and the bottom, and if you don't need anything, leave it as is. Okay. So, the LCD, p plus 3, p minus 5. So, this, we need a p plus 3. P plus 3. P plus 3. Good. This over here, we need a p minus 5. Okay. Over here, we need a p minus 5. Great. Now let's continue to solve. Up here, if I just distribute this, we get 3p squared plus 9p divided by p plus 3, p minus 5, plus a negative 2p plus 10 divided by p plus 3, p minus 5. And I have a, let's see, equals p squared minus 5p divided by p plus 3, p minus 5. Now, what's nice about this is when you have all of the same denominator, wipe it out, gone. Now we just set this up top equal. So, we have 3p squared plus 9p minus 2p plus 10 is equal to p squared minus 5p. Now we combine like terms. 3p squared plus 7p plus 10 equals p squared minus 5p. move everything to one side and solve. So we have 2p squared plus 2p plus 10 equals 0. Pull out a 2 because that is the GCF. Set it equal to the number 0. What is going on here? I'm sorry, that should not be a 7. I'm adding the 5p. No, I'm sorry, that should be a 7. It should be a 12p. We could still factor, though. That should be a 12p. And this over here should just be a 6p. All right, good. Everything else is good. Sorry about that. Now, we are going to perform some factoring. What adds to positive 6 and multiplies to give you positive 5? That's just going to be p plus 5, p plus 1. Set that equal to 0. The 2 just wipes out. We get p equals negative 5, and p is equal to negative 1. Now, I am not going to waste my time, or yours. I will tell you right now that these are both your answers. They both check out in the question. Plug them back in. I'm sure all of you could plug things back in. Plug it back in. They both equal. They both check out. There's nothing wrong with them, and they are good to go. Those answers are correct. Negative 5 and negative 1. Moving on to number 34. Simon lost his library card and has an overdue library book. That's not good. When the book was 5 days late, he owed $2.25 to replace his library card and pay the fine for the overdue book. When the book was 21 days late, he owed $6.25 to replace his library card and pay the fine for the overdue book. Suppose the total amount Simon owes when the book is n days late can be determined by an arithmetic sequence. Determine a formula for a sub n, the nth term of the sequence. So, you're thinking of an arithmetic sequence, which is a sub n is equal to a sub 1 plus n minus 1 times the common difference d. So, we already know that, let's see, where is this? What is a sub 1 in our case? Simon lost his library card for an overdue library book. When the book was 5 days late, he owed $2.25 to replace the library card. Okay, well, let's figure this out real quick. Let's figure out the common difference. Well, the common difference is, well, it's $6.25 minus the $2.25 divided by the 21 days late minus the 5 days late, and that's just a common difference of 1/4. So we know for sure that a sub n is equal to a sub 1 plus n minus 1 times the common difference of 1/4. Okay, so now what is the first term in this sequence? So the first term in this sequence is actually quite challenging to pinpoint out. It says here specifically that everything for his late fee is to replace his library card and pay the fine for the book. This common difference here, ladies and gentlemen, this is the fine to replace the book. And to replace the book costs 25 cents. Well, how much is it costing to replace his library card? Well, in order to determine that, all you do is you take the $2.25, right? And subtract the 25 cents, so that's 0.25 times the 5 days. And that is just going to be $2.25 minus 1.25, and that's just going to be $1. As far as I'm concerned, so it actually costs $1 to replace his lost card. So what is a sub 1 now? Think about it. A sub 1 is the first term on the first day that the book was late. Well, they charge you 25 cents for the late book, and they charge you $1 to replace your card that you lost. So so a sub 1 is actually going to be $1.25. And that, ladies and gentlemen, is how you set it up. That was the tricky part of that question, not gonna lie. So this is actually your answer. A sub n is equal to 125 plus n minus 1 times a fourth. Now for the second part of the question, it says use the formula to determine the amount of money in dollars Simon needs to pay when the book is 60 days late. Honestly, if it's 60 days late, you should just buy them a new book because it's going to cost a lot of money. So a sub 60 is equal to $1.25 plus 60 minus 1 times 1/4. Plug this into your calculator and solve. A sub 60 is just going to be $16. That's exactly how much he's going to owe after 60 days. Plug it in to your calculator, get it, and solve. You answer $16. Moving on to number 35. On the set of axes below, sketch at least one cycle of a sine curve with an amplitude of 2, a midline of y equals -3/2, and a period of 2 pi. Well, this is interesting. So let's talk about this for a second. So the amplitude is 2. So that is the vertical distance from the midline. So I'm going to sketch this as best as I possibly can. And I'm going to use some dotted lines here too. That's important stuff. So let's take a look here. This is going to be y equals -3/2. Okay. Now the amplitude is 2. So the amplitude, I'm going to give this a different color here. So the amplitude is going to be 2. That means we take -3/2 plus 2. That's actually just going to be 1/2. So 1/2 could be up here. Let me draw this a little bit more to scale. Make it like, oops, my apologies. Let me put this blue line a little bit down more. Like that. Yeah, that's good. Okay, so y is equal to -3/2. That's good so far. This up here, this is y is equal to 1/2. And of course, you have to go 2 below it as well. So 2 below it is just going to be -7/2, right? So that looks good, right? So we have y is equal to -7/2. So far, so good. Now it's asking you to sketch with a period of 2 pi, sketch at least one cycle of the sine curve. So one full cycle. That means you're going from -3/2, the line y equals -3/2. You're starting at this point. You're going up to y equals 1/2. You're coming back down, going down one more time, and you're coming back up to the line y equals -3/2. So this is how it's going to go. I'm going to slowly sketch this because my drawing style on this software is not that great. So bear with me while I draw or attempt to draw my sine curve. It's going to be ugly, but it's the best I could do. Okay, that's not too bad. So this right here, this point right here, that's actually pi over 2. I'm going to label this a different color. So this is pi over 2. This over here, this is pi. Down here, this is where 3 pi over 2 is. And this up here, this is 2 pi. And that's exactly what we did. We sketched it with a period of 2 pi, meaning one cycle occurs in 2 pi radians. And that, ladies and gentlemen, is how you sketch it. Not too bad of a question. Annoying, but not too bad of a question. Now, I assume that there's a follow-up because this is a part 3. The follow-up is, explain any differences between a sketch of y equals 2 sine of x minus pi over 3 minus 3/2 and the sketch from part A. So what's the difference between this? So notice here from this equation that the amplitude is 2. That's just the number in front of the sine. There's a horizontal shift here of pi over 3 units to the right. And it's a vertical shift down by -3/2. Well, what's the difference between these two? Actually, let me display a dual page here. What's the difference between this equation and the graph shown? Well, it's certainly being shifted down by -3/2. That's no difference, right? So that's actually good. The amplitude is still 2. Yeah, that's good. But this isn't being horizontally shifted anywhere, right? So that's the difference between these two equations. So basically what you're going to say is that the sketch from part A, I should be more specific, the sketch from part A would be shifted to the right by pi over 3 units. And that is how you do that part of the question. Moving on to number 36. Using a microscope, a researcher observed and recorded the number of bacteria spores on a large sample of uniformly sized pieces of meat kept at room temperature. That's disgusting. A summary of the data she recorded is shown in the table below. Using these data, write an exponential regression equation, rounding all values to the nearest thousandth. Oh, these are so simple, right, people? Go to your graphing calculator, go to your list and spreadsheets, and I'm going to list these. So this is hours, also called X. Of course, they can't accept that because there's parentheses in there. So I'm going to call these hours. You can call it whatever you want. And this is the average number of spores. I could do that because I have a keyboard. So you might just have to type in X and Y. So this is 0, 0.5, 1, 2, 3, 4, 6. Be careful with that one. 4, 10, 15, 60, 260, 1130, and 16, 380. Okay, so now that we have this, do Control Doc, add a calculator page. I like it on a nice clean page. Go to menu, go down to statistics, go to stat calculations, go to exponential regression because that's what we're looking at here. The X list is the hours, the Y list is the average number of spores. Click OK, and this is what we have here. Now, for those of you who are using headphones, turn down the volume. I'm not sure if I turned down my volume because I have to take a screenshot of this and put it on my software. So that's a warning to you. Make sure you cover your ears. Here we go. I'm not so sure if I turned it off. Told you I didn't turn it off. Okay, so let's go back. I'm going to paste this. Paste. Okay, so we got this. That's good. Now, here's what you need to copy down when you're doing your Regents exam. So you're probably thinking, oh, Trevor, what do I copy down? Well, I'll tell you what you need to do. You need to write down the title. You could write down the regression equation. You need your A value and your B value. That's all you need. You could get rid of all this other stuff. So that's what you need to write down in your exam. Now what you need to do is on the right-hand side, just say like, write an exponential regression equation. It's an equation, so you have to write somewhere of y equals. Since it's an x and y, I'm going to write y equals. So y is equal to, and it says round to the nearest thousandth. That is 3 decimal places to the right. So that is going to be 4.168 times 3.981 raised to the x power. Ladies and gentlemen, that is the answer to this part of the question. Not too bad. Moving on to the second part. The researcher knows that people are likely to suffer from food-borne illness if the number of spores exceed 100. Yeah, damn right. Using the exponential regression equation, determine the maximum amount of time to the nearest quarter hour that the meat can be kept at room temperature safely. So here's what's going on here. They are basically telling you to take this equation and set it equal to 100. They want to know what's the time, because x is in time, it's in hours, right? So they want to know the value of x where it equals 100, because the minute it reaches 100, if it exceeds 100, that's a problem. So it's 100 is equal to 4.168 times 3.981 raised to the x power. We're going to solve for x. Of course, since x is in the exponent, we're going to be using logarithms. So divide by 4.168, divide by 4.168, 168. 100 divided by 4.168, that's going to be 23.99232. That is equal to 3.981 raised to the x power. Now we're going to take this x, we're going to move it out to the front. Now the minute you write the exponent down here, and it's a letter, so if it's a variable and you move it down in the front, you have to write the word log. So it's the log of 3.981. Now the minute you write the word log on one side, you have to take the log of the other side. Okay? That's what we have so far. Now let's solve for x. We're going to just divide these things here. So we're going to divide by the log. Divide by the log of 3.981. Divide by the log of 3.981. That cancels. We have x is approximately equal to, type this into your calculator. I'm not going to do it because I'm lazy. That will give you 2.3-ish. No, I'm sorry. That will give you, it says, wait, approximate to the nearest quarter. Okay, so quarter hour. So this is x equals approximately 2.3. Well, it's 2 hours and like 3/10 of an hour. Well, it says the nearest quarter hour, so that's just going to be x is equal to 2.25. That was the killer there. Make sure that you round to the nearest quarter hour. 2.25 is your answer. Moving on to the final question of this exam. We're rolling here. 37 says the value of a certain small passenger car based on its use in years is modeled by V of t equals that, and where V of t is the value in dollars and t is in time and years. Zach had to take out a loan to purchase a small passenger car. The function z is that, where z of t is measured in dollars and t is the time in years. Models the unpaid amount of Zach's loan over time. Graph v of t and z of t over the interval from 0 to 5 on a set of axes below. So, this one is, you're really just watching me graph some things. So I'm just going to go to my graphing calculator here and type in these equations. It's going to be a nice pain in my neck. So I'm going to type in v of t first. So v of t is 28,482.698. Wow, this is a long one. Times 0.684 raised to the, okay, so it's t, it has to be an x for the calculator for it to work. And this is 22,151.327 times 0.778 raised to the x power. Now the problem is you're not seeing it on the calculator because it's so big. So what I'm going to do is I'm going to do menu, zoom, and zoom fit it. So that's good. So we just fit this in here. Now, actually, it's saying from 0 to 5. Okay, so let's fix that a little bit. So go to menu, go to Windows Zoom, click on Windows Settings. You're going from the X of 0 to 5. I'm going to make the X scale 1. I'm going to make the Y minimum. I'm going to make that 0. I'm going to make the X maximum. Okay, well, the initial amount for... Okay, so the initial amount for V of t is 28,482. So let's just make the Y maximum 30,000. Right? That would probably be most appropriate in the context of this problem. So 30,000. Let's make the auto, I don't know, 10,000. Click OK. That's better. We're good so far. Now what we're going to do is basically graph that. So, what you want to do yourself is to basically label on the side here. So I'll label it for you as well. You need to create a table of values. So this is for V of t. I always forgot how much of a pain in the neck these questions are because they're so long that I just don't like to do them sometimes. I'll move my head in a moment. Actually, I'll just extend the page. 28,483, 19,482, 13,326, It's nice to have an answer key when you're doing this stuff. Okay. And we have z of t. Z of t. So this is x and y. Okay. 0, 1, 2, 3, 4, 5. $17,234. So these numbers should match what you have on your paper because you did it already, right? You're not cheating? Just making sure. Okay, so now we have this. We're going from 0 to 5. I'm going to label appropriately. So I'm going to make this 0. Let's go every 3. 1, 2, 3. Yep, make that 1. 1, 2, 3. Make that 2. 2, 3. Make that 3. Make that 4. Make that 5. Okay. Now I know that I stopped at 30,000. So I'm going to count by, I believe I counted by 2,000. 2, 4, 6. Yep, I counted by 2,000. So 2. Actually, I counted by 10,000s, but technically by 2,000s. But I just labeled the 10,000. So 2, 4, 6, 8. This is 10,000. 2, 4, 6, 8. This is 20,000. 2, 4, 6, 8. 30,000. Okay, so we definitely know it's up there somewhere. So at 0, this is 28,483. So that's like right there. So now I'm just basically drawing it. So 1, this is 19, so it's around here in this vicinity. 2 is 13. 10, 12, 13 is somewhere up here in the middle. 3 is 9, about 9,000. Right around in the middle too. 4 is 6, 2, 4, 6. Around there. And 5 is 2, 4, around there. Okay, so I'm going to, again, sketch to the best of my ability. Because this is annoying. Come on, Trevor. Yes, okay. So, don't draw arrows. Do not draw arrows because it specifically says from 0 to 5. If you drew an arrow, I believe you drew an arrow on both of them, you got a point off. Now, for the other one, let's see. This starts off at 22. Right over here. 17. 10. 12, 14, 16, 17 is about halfway. Then at 2, it's 13. So that's 10, 12, 13. Oh, it's really close over there. Really close. This one over here. So 3 is 10. 10,000 somewhere up there. 4, 2, 4, 6, 8. A little bit over here. And 5 is 6. 2, 4, 6. Around there. So it looks like it's intersecting somewhere by like x equals 2 or something like, or t equals 2 or something like that. So that's basically all you need to do for that one. That's how you graph it. Is it annoying? Of course it is. But it's doable, right? Honestly, I could have just graphed, I could have just taken a picture and graphed it myself, but I'm not that mean. But I have to do it for the next part because it says here, state when v of t equals z of t to the nearest hundredth and interpret the meaning in the context of the problem. Well, I actually need to do menu, analyze graph, intersection, click before and after. And this, ladies and gentlemen, is what they're looking for. They're looking for the x value because they're asking you for the time. Yeah, they're asking for the time. Actually, are they asking for the time? Yes, they are. They're asking for the time. So your answer is 1.95. So you're going to say that t is approximately equal to 1.95. And what does it mean in the context of the problem? Well, you're going to say at 1.95 years, the value of the small passenger car equals the loan balance. And that's how you interpret it. Done. Moving on to the next part. Zach takes out an insurance policy that requires him to pay a $3,000 deductible in case of a collision. So he has to pay $3,000 for the insurance. Zach will cancel the collision policy when the value of his car equals his deductible to the nearest year. How long will it take Zach to cancel this policy? Justify your answer. So it's saying that the value of his car equals the deductible. So basically what they're asking your knowledge here is, you see how V of t is the value of his car. So here's the thing, and I want you to understand this. And I know that all of you are high school students. Most of you probably don't even drive. If not, all of you don't drive, unless you're taking Algebra 2 in senior year, which that's okay, by the way. But what does that mean? Well, if you have a collision policy and you pay out $3,000, eventually over time, your car does depreciate. I mean, my car is a 2010. It's depreciating over time. So when it depreciates over time, it gets to a certain point where the insurance exceeds the value of the car. So you should be paying less insurance. So here's the thing. If Zach's car dips below $3,000, let's just say, God forbid, he gets into a crash, and his car is only worth $2,500 or $2,500. Why is he paying $3,000 for his deductible? His car's not worth that much anymore. His car is actually worth less compared to his deductible. So it's very wise of him to cancel that $3,000 deductible because his car is not worth it anymore. So basically, you're taking the value of his car, so the function of V of t, and you are going to find out where it dips below $3,000. Well, I'm looking over here on my table of values. After the 5th year, it's about 4,242. I'm going to go to my graph page real quick and click Control T. It's the blue function. Go down to 6. Ooh, wait a minute. After the 6th year, his car is $2,916 now. That's below $3,000. So basically what you're going to say is oh, okay, wait a minute. V of 6 is actually $2,916.87. Well, how many years will that take? Well, that's technically 6 years that went by. Well, if we take a look here at his deductible, V of 7 is greater than or equal to $3,000. It's the 8th year. So why would he pay 2 more years? That makes no sense to pay 2 more years, right? So we're actually going to, well, V of 7, as we just concluded, it has to be greater than or equal to 3,000, and it's not, right? It's so not. So it's actually year 6 that he needs to cancel his policy. It just makes no sense after the 6th year to just start paying more money, or just to have the $3,000 deductible anyway. Even if he gets into a collision, it's not worth fixing his car, right? And that's how you do that question. All right, that is the conclusion of this exam and this video. Make sure that you hit that subscribe button down below. Consider becoming a patron on my Patreon page, and visit my website at www.nysmathregentsprep.com for more math content in Algebra 2, and I hope to see you soon.